In this video, we're going to learn about cells and batteries, and we'll learn the difference between a cell and a battery, and we'll learn about the components of simple cells. So before we had invented batteries, Luigi Galvani in the 1780s was performing some experiments with frogs' legs. So he had pinned down some frog legs with brass hooks, and he started cutting into the frog legs to perhaps explore the muscle, I'm not really sure. And his steel scalpel hit the brass hook in the frog leg, holding it down, and he observed that when he did that, the frog leg twitched. So he decided to try it over and over again, and he saw that it was reproducible. So he believed that there was some sort of electrical force in the muscle of the frog, and he was proving that fact. So he thought that the electrical force was within the frog's leg. Now, Alessandro Volta, in the early 1800s, kind of disproved Galvani's idea. He realized that there was something else involved. So he felt there was something in the frog's leg that was allowing electricity to be generated, but it wasn't actually the frog's leg that was producing the electricity. So Volta ended up creating voltaic cells. So these batteries, these precursors to the batteries. So he discovered if you stacked metal discs, and his first battery involved silver discs interspersed with zinc discs, and in between those he would put a piece of cardboard in between that had been soaked in salt water. And if he kept doing this layering of the silver disc, some cardboard soaked in salt water, a zinc disc, and so on, he called these stacks piles, which is why sometimes batteries can be called piles. And when this happened, it actually generated electricity. So he was actually able to disprove Galvani's theory that it was the frog's leg that was creating the energy. Instead, it's two opposing metals interacting with an electrolyte. So that's what the salt water was acting as. So now we're going to look at what makes up an electronic circuit. So a simple voltaic cell has a few parts. So one thing it has is an electrolyte. So that electrolyte can be either in liquid form or in paste form. So if it's in liquid form, it's called a wet cell. And if it's in a paste form, it's a dry cell. So the batteries that we use where we can put them in devices, those are actually a paste, so those are dry cells. An example of a wet cell would be in your car battery. So there's actually a whole bunch of cells within there, and the electrolyte is a liquid, and that liquid is sulfuric acid, and it's very corrosive, so you don't want to spill the electrolyte from a car battery on you. All electrolytes are somewhat corrosive because they typically are acids. So in this voltaic cell, in this simple cell, we have a zinc electrode, which will end up becoming positively charged, and then we have a copper electrode, which will end up gaining a negative charge. And then we have our electrolyte, like I mentioned, and in this example I've thrown a light bulb into the circuit to show that the electricity can flow through and light up the light bulb. We're going to talk about how simple cells work. So when you turn on a device, a chemical reaction occurs, and the chemical energy that's in the reaction will be converted to electrical energy. So this reaction produces a flow of electrons. These electrons are going to flow from the positive electrode, in this case it's zinc, through the wire, and then back to the copper electrode. And in the meantime, those electrons are flowing through a load. In this case, it's a light bulb, and it causes the light bulb to change to produce light, and then the electrons go back to the copper electrode. And this reaction will continue until either the device is turned off, or either the electrolyte or electrodes get used up. So cells and batteries are similar but different. So what we tend to call a battery is really a cell. So a AA battery is actually a cell, not a battery. And when you combine them into multiples, which is usually what you have to do in a circuit, those would be called a battery. So battery is multiple cells put together. So one battery is a cell, and multiple cells make up a battery, if you understand what I mean. We also have two different types of cells. So primary cells are single-use cells. So they get thrown away once they're used up, and hopefully they are disposed of appropriately, because the chemicals that make up cells and batteries are actually quite harmful for the environment. So we need to dispose of them in a safe and environmentally friendly way, so recycling them. So we have recycling programs. We just had a pickup of batteries in our household waste in our recycling program. In twice a year that happens. So it's a good idea to collect all those batteries and save them up and recycle them instead of sending them to the garbage, where those chemicals could leach into our landfills and into our waterways and actually poison us and the environment. Secondary cells are rechargeable, so you can use them over and over again, because there's actually two chemical reactions that occur. So one chemical reaction occurs to power your device, and then once the electrolyte and the reaction stops, you can then regenerate the original chemicals back, and you can use the battery again and again and again. So right now we're going to talk about different battery types. So these letter codes actually just mean the size. So a AAA battery is smaller than a AA, which is smaller than a C, which is smaller than a D. And they each collectively have more or less electrolytes, so they can last longer than some of the other ones. So all of them, no matter their size, actually have the same voltage. They're all 1.5 volt batteries, but the AAA would have less electrolytes and would last less long than a AA and so on. So AAA batteries, you usually use them in mini flashlights, or you might find them in your remote for your TV and so on. A AA would be, you could use those in flashlights as well. I always use them in my Walkman, but those don't exist anymore. But you could use those in remotes as well. You could use them in like games. So my old Game Boy used AA's. A C might be used in something like a radio, a portable radio that you might use, a bigger flashlight, and so on. A D cell, same thing. You would use them in larger devices, something you want to last longer. So my portable lantern operates off of D cells. A big mag light flashlight, those ones that police or janitors or security people might carry, those would be examples of D cells. My big boom box used to have D cells as well. Flat circular batteries, you would find those in watches and hearing aids and so on. A 9-volt battery, one place that you would find those would be in smoke detectors. Now, a lot of our smoke detectors are actually hardwired in to our wiring in the house, but there's always going to be a backup. So smoke detectors would be an example. A 12-volt battery would be in your car. A nickel-cadmium battery is a rechargeable one. The ones that you would plug back in and recharge so you can use them again. A lithium-ion battery would be in your computer, so a laptop, in your phone, and so on. So they're rechargeable, but you plug them in to recharge them, and then you end up being able to use it again.